name's Shane. I'm an associate professor at the University of Waterloo. So the first question you should have is like, why is this invader here? And I'm going to try and answer that at the end of the talk. But before I get there, I want to tell you a little bit about some of the work that we've been doing in my research group on code review and my vision for where it can go. And the talk is called Incorporating Broader Development Contexts into Code Review. So I'm going to begin with like the kind of core part of what a code review revolves around, and that's this patch, right? And I recognize that a patch is a very pragmatic choice for making a code review, right? We can generate a patch using the textual diff tool, which can be applied to all sorts of code and code-like artifacts. But the argument that we make with my work is that these patches miss the broader context, right? And maybe an author might have questions when they're developing a patch, like, does my change set impact the right set of deliverables? And maybe a reviewer, slightly less handsome and cunning compared to the author, they might have questions like, which users are impacted by this change? And a diff, a textual diff, is never going to be able to help you answer this, right? To me, a textual diff is like this picture here. It provides you with a very fine-grained perspective of what's going on, but if you take a step back, you can miss the forest for the trees, right? And what we try and do in my research group, at least recently, is to try and enhance this code review experience with other contexts. So for example, we try and incorporate a historical context. So if you're changing files that have been bug-prone in the past, maybe we can provide that information in the code review interface to help make better decisions. We try and incorporate the deliverable context. So you're changing files. Those files might only end up in deliverables under specific constraints. Let's say the Mac OS X variant of your product. And incorporating that kind of information can also enrich code review. We try and leverage operational data. So if you know your customer workloads, you might be able to say, okay, you're changing code that affects all of the workloads of the systems in deployment, or it's just affecting one small customer who doesn't provide much revenue, so maybe we don't need to review it so carefully, right? And the final piece is this concurrent development idea. So you're changing code, others are changing code around you. It would be nice to kind of keep track of that in the code review interface as well. Now, I don't have the time to go into all of these areas. I'm going to spend time on the deliverable context today, just because that's where my heart lies. I wake up in the morning and I think about build systems. I love build systems. So let's talk about build systems. But before we get there, let's talk about the context that this work is motivated by. So a couple of years ago, I read a paper about when testing meets code review. And what they were studying is how does the code review of test files compare to the code review of production code. And one of the things they found is that test code, when it changes, is about 2 times less likely to have a discussion than production code. Kind of not super surprising, but interesting. And they argue in this paper for all the different ways that we can enhance code review to make testing a more interesting and fundamental part of the process. So the natural question for a guy who wakes up thinking about build systems is, what about build code, right? It's also an artifact that's changing. And it's also an artifact that, like test code, doesn't have tests. So people don't test their test code. They just assume it's correct. And they rely on code review to catch problems. Just like that, build systems kind of this fundamental layer. We assume it's correct. But we need code review to catch the kinds of problems that are going on there. And why would you care about reviewing your build specs? Well, if you don't do a good job of maintaining your build specs, all kinds of things can go wrong. Now, I should have used the XKCD comic that everybody uses about the two guys with swords fighting, and their builds are still running, right? So they're slacking off. But slow builds in general have a problem. It's not developers slacking off, better believe it or not. It hinders release cadence, right? So if your builds are slow, you can't produce releases as fast, and it makes your organization less agile, right? You just can't keep up. Now, if you make mistakes in your build system, it can have other kinds of problems as well. It can even impact your users. So the example I show here is of Firefox. There was a release of Firefox a few years ago that wouldn't work for users with home directories that were mounted over the network because in their build script they had linked an incorrect version of a library. So because they made a bug in their build, users with home directories that were mounted over the network couldn't access the address bar and search bar. Now, I don't know about you guys, but when I use a web browser, those are kind of the only things that I'm using. So it can have a big impact. So the question we asked is, do developers actually review build specs? And this is where I get to show off my poetic language. We studied 4 Ps, okay? We studied the prevalence of reviews on build specs. We studied the purposes. We studied the patterns. And we studied the perceptions. So prevalence, we're just looking at how often it's happening. Purposes, we want to know what actually is the point of the comment that they're making. Patterns are about the code that's being commented on. And perceptions, we actually talk to engineers not unlike yourselves to ask what they expect and what they think about code review on build specs. So I'm going to give you a lightning tour of this paper. First, let's talk about the prevalence. So I kind of skipped a slide where I tell you about the projects that we studied, but we looked at the Qt system, which is written in C++ and is very, very big and popular. We also looked at Eclipse. So that's a Java system with a different kind of build spec. And what we found is not unlike these test researchers, we found that build files are even less likely to receive comments than test code. So in the examples that we analyzed, 16% of source files, when they change, had some discussion. 12.5% of test files, when they change, had some discussion. And only 5.87% of build files, when they change, receive some discussion. So what do we take away? Well, discussions on build files are rare. So when they happen, what's the purpose? What are people discussing in the review of build files? So to do this, we used kind of the same theoretical underpinning as they use when they do political polling. Now I know that's probably sounding like magic that is unreliable, but I can assure you that it is pretty reliable most of the time. So we drew a random sample of 500 comments. Now this random sample of 500 comments is drawn such that we get a 95% confidence that the true measurement, if we checked everything, would be within 5% plus or minus of what we measured. So 19 times out of 20, the measurement we're reporting is within 5% of what it is in the population. Now the reason why we drew a sample of 500 is because each one of these comments were independently checked by all 3 of the authors. And that's Maddie, my PhD student at the top, Mahmoud is a postdoc in my research group, and myself. So we each kind of went into separate rooms and looked at this whole pile of 500 comments, and we did what's called closed coding. So closed coding means we all know what are the possible categories we can put this into. And this comes from the literature. So there are code improvement comments, there are defects that people are pointing out, there are understanding kind of questions that people raise, there's knowledge transfer that happens during code review, and a few others. The thing I want to highlight here is that we compared to reports from the literature that have done similar studies at like Microsoft and Google, and we're finding that in the code review of build changes, the discussions of defects are much, much more prevalent. So 36.2% of the comments that we sampled were pointing out bugs in build files. Whereas when people study source code, it's only about 14% of the comments are talking about defects. So what's going on? Why are people raising comments on build files? Well, defects, defects, and more defects. Next, let's talk about the patterns. So where are these comments being applied? For this, we did a very similar thing. Again, we sampled a large number of reviews, and each one of us was going to check it. But this time, we checked together to do what's called open coding, because we didn't know what the categories were ahead of time. We were going to discover them as we were coding. So that first step of coming up with what the catalog looks like is done using open coding. And then after the open coding is complete, we do what's called card sorting to make a hierarchy. I'm just going to focus on the top level of the hierarchy, but I can talk to you guys more about details offline. So there are 6 different categories at the top level of the kinds of targets for these code review comments. So they might be about evolvability. So how can we make the build scripts easier to maintain going forward? They might be about external dependencies, so package versions that need to be integrated, and other sorts of external dependencies that need to be managed, such as tools. It might be about the build behavior itself. So what is actually going to happen? Are we going to skip this or that step in this particular scenario? It might be about the file system configuration. This gets broken down into a logical and physical view of the file system. There are a lot of comments about the build language itself. We'll see when we get to the perceptions section why there's so much discussion about the build languages, but this is about the semantics and the syntax of the change themselves. And finally, there are some miscellaneous ones that didn't really fit into a nice category, one of which is like getting their change to work in Gerrit, which is kind of funny for this group. What kinds of patterns do we have? Well, we have evolvability, external dependencies, and build behavior kind of driving what's happening during these code reviews. And the last step, we interviewed people from the Qt organization and from Eclipse, some of which have like 40 years of experience in development, to try and ask them what they think code review of build systems is and why we were observing what we're observing. So I'm just going to, at a very high level, highlight some of the key takeaways. So code review of build specs is hindered by social and technical challenges. So from the social aspect, there's a lack of expertise. So this particular build engineer gave us a nice quote where he said, anybody who changes the code has to change the build from time to time, and often they aren't familiar with the build system. I can tell you from my personal experience, when I used to work in industry, there were people who were like the most amazing engineers who could like recite the C++ standard forwards and backwards. They could design things way better than I could. But then you ask them to edit a build script and they act like a first-year undergraduate student. They're just like copy-paste hacking and doing all kinds of crazy stuff. So there's this lack of expertise. And a natural follow-up is, why is there a lack of expertise? Well, it's probably because developers aren't like me. They don't wake up thinking about build systems. They rather just work on the system itself. And one quote from an engineer we talked to is exactly that. All I care about is the ability of building my program. I'm just going to hack it to get it to work. And the last one is the technical challenge that I think is interesting. One of the build engineers at Qt was telling us that they would rather have better tools for maintaining build files than to improve the social problems that we highlighted. Like we asked them, you know, if you could have a magic wand and make a problem go away, he said, I wanted a great tool to help make maintaining the build better, because even if engineers started to care about build scripts, they're going to come and go, but the tool would stay. So there's a nice little summary of this build spec stuff. I know I'm running short on time. I'm going to give you a lightning tour of what we can do. So one of the things we've been doing in my group as well is to make some tools, right? Let's leverage the build to make code review better, right? And this here is a perspective of what your software system looks like from the build's code perspective. We call it a build dependency graph. It's been extracted, and it includes the conditional branch operations, right? So the yellow nodes say, you know, if I'm on Windows and I'm on an x86, compile this way. If I'm on Linux, compile that way, kind of thing. And the green nodes at the bottom are our source files, right? So what we want to do is leverage this data source to improve code review, right? Like I said at the beginning of the talk, like patches are great, but I think we can enrich it with a lot more information. So wouldn't it be great if when you submit your patch, we'd be able to like highlight the areas of this graph that are impacted by your change, right? Now I am a professor in a mathematics department, one of the only mathematics departments in the world. Like a faculty of math, I mean. So I have to show you some math. It's just my job, right? So if this graph is like a sphere, think of it like a sphere, and we want to know what the surface area of the sphere is. Well, we all remember, I'm sure you don't need me to remind you how to calculate the surface area of a sphere. It's 4 times pi times the radius squared, which can be rewritten as pi times the diameter squared, which can be rewritten as d times pi times d, which explains why we named our tool DippyD, right? So our tool is called DippyD, and what it does, I'm not going to go into detail about this. Think of it in 2 phases. So first, we take all your build files and we build an index, kind of like a search index, that we later then use patch sets as queries against, right? We query our index to try and figure out what the impacted red nodes might be, okay? And what we did, so I talked about this actually at the Gerrit User Summit a few years ago when we were online, and I recruited actually some participants for this study from this place. So I'm back to report kind of what some of the outcomes were. So what we did is we selected real patches from real software systems, and we manually defined what the ground truth was. So myself and my student, Mehran, in this case, went through these patches and said, okay, these are the red nodes, these are the deliverables that are impacted by these change sets. Then we took a pool of participants and we split it up kind of like a controlled drug trial, where we said, okay, one group, we're going to give you the patch set and we're going to give you the DippyD tool. One group, we're going to give you the patch set and we're going to give you a static analysis-based tool. So this is still like dependency-based, but only from scanning the code, not from scanning the build files. And then the other group is given nothing, just to see control for the placebo effect, right? Okay, And then we asked each group to complete the same tasks, assess the exposure of the change, and we compared to the ground truth to be able to answer 2 questions. How effective are the different groups at finding the right deliverables? And how efficient are they? Right? Maybe you're equally effective, but you're faster using the tool, something like that. Okay? Now, we gave 3 different tasks in the study. I'm only going to talk about one because I'm really running out of time now. So the task itself was, okay, we give you a patch and we ask you which deliverables in this list of deliverables are impacted. Okay? Now, here's how the 3 groups performed, 3 different rows. I recognize that precision and recall are not like super familiar, but they are measurements of information retrieval. So precision says, when you tell me that this deliverable is impacted, how often are you correct? Okay, and what we're finding is the no tool group, it's as good as a coin flip. 50% of the time they're correct when they say this is impacted, 50% of the time they're incorrect. The static impact tool improved that to 60%. And then when they were using DPD, it went up to 94%. So really a substantial improvement in how often people are correct when they say something is impacted. Now, recall is the other measure we often use in information retrieval. It says, okay, of all the things you should have found, how many did you find, right? So in terms of recall, we find the no tool group finds about 33% of the truly impacted deliverables. The static analysis goes up to about 50%, a little bit under. And then with DPD, we find almost all of them, 94% again. The F1 score here is just the harmonic mean between precision and recall. So if you consider them both equally important, being correct when you say something's impacted and finding all the things you should find, then the harmonic mean gives you a good overall measurement of that. And there's also the efficiency measurements we did. This is in seconds, and I'm going to tell you right now it's inconclusive. Okay? You can look at the standard deviation column on the far right, and you'll see, like, even though we are on average faster, the standard deviation brings you below or above like the next best group. So the takeaway from this is that using DipED, we can definitely say you're much more accurate and much more effective at finding the impacted things. But in terms of time, I don't think there's much of an impact. Okay? So that gives you kind of a quick overview of some of the work we've been doing on this like idea of lifting away from patches and complementing it with additional information. Quickly, I want to do another recruiting call. Okay, so lately we've been working a lot on automated code review. So kind of the AI takeover is here, right? And hopefully it's not going to be like the Terminator series. It'll look more like this, where humans and bots are working together. And two ways that we're trying to enhance studies of automated code review in my group. One is how often are the incorrect recommendations complementing what human reviews do? So today, when we assess an automatic code review, we just try and see, does it do exactly what the humans did? We say whatever happened in the real review is the perfect ground truth, and if the automatic code review tool can produce the same comments that humans did, then it's great. If not, it sucks. And I think that's kind of a narrow perspective. So instead, what we're trying to do is we're collecting these things that are not exactly what the humans suggested. We're running the automatic code review tool on old reviews from the Gerrit community, and we're seeing when it's not exactly what the human recommended, and we're putting together these personalized questionnaires for the people who participated in those reviews to ask you guys, do you think this feedback would have been useful? Now we're collecting these reviews from the last year or so, And you may have already received an email about participating. If not, and you are interested, please let me know. And Oat, the student whose picture is in the top left corner, he's a collaborator from Australia, and he's driving this, and I'd be really, really happy if you guys would participate. The second thing about automatic code review is this one from Farshad. He's in the middle left here. And he's noticed that these automated code review tools, because they're trained on the code reviews that have happened in the past, they tend to repeat the things that happen in code review. And one of those things is asking questions. So this code review bot might ask you, why is this needed? Now, this is great, but the problem that we have is that these bots are not interactive. So they'll ask you a question like, why is this needed? And then you write a nice response and never hear back from the bot, right? So they can even ask like super complicated questions like, you know, can the user add these two options here? And, you know, these kinds of code review questions were intended to spur on a discussion that they're not going to participate in. So what Farshad is trying to do is figure out how often these questions are still useful, considering the bots won't engage with you. Okay, last point to make, okay? So I'm here as a kind of infiltrator to your industry meetup because I firmly believe that we can benefit from each other. So industry plus research with my Software Rebels group leads to profit, and I'd love to chat with you guys about all the different ways we can work together. We have some industrial collaborators already, so they come from all sorts of domains. We work with video game companies. We work with the big tech companies like Shopify, Dell. We've done some stuff on mobile development with Sony. We've worked with small companies like this startup called Yourbase. And hopefully we can add your organization here. Okay, so what did I talk about? I talked to you a little bit about my vision for what an enhanced code review interface could be. And I really think that Gerrit is in a really great place to incorporate some of these things. Talked about historical, deliverable, operational, and concurrent development perspectives. But I focused on the deliverable one. I gave you guys a little bit of an overview of a recent paper we did on code review of build specs. You can access the paper at that QR code in the bottom left if you're interested. I talked to you a little bit about DPD, which is kind of like a return visit after we did the study, and found that DPD is quite good. You can read all about the report of its performance and the study here at that QR code. And finally, I talked a little bit about how you can participate in our studies. Hopefully you're interested and will contribute some of your time to help us. Or if you're interested, we can talk about collaborative projects we can do together. Thanks for your attention, everybody. So currently it works on CMake build specifications, but to get it to work on other build specs, that could be an interesting project. I'd be happy to talk about how we could make that happen as well. We focused on CMake and C++ based builds because those tend to have a lot of compile time variability, and that is where the interesting, rich graphs come from, less so for interpreted languages. It is open source, but I can tell you it is written by a master's student who hurriedly wanted to graduate. So if we want to turn it into a reliable tool, I think that would be a really cool project as well. But it would take some effort. More like a proof of concept, right? We wanted to see, will this idea actually work? And the results from the user study suggest that people are way more effective with this information. And I think that's all the research that we need to kind of push this into the development world, where you guys could take over and get rich off my ideas. Funny guys.
Did you have the chance of trying it on a real use case in the industry? Like the company that you were mentioning, or a company that actually tried it?
Yeah. So DipED's predecessor, which was written by another student of mine, was developed in collaboration with one of my industrial partners I listed. And they're using the tool that we developed in-house for them as part of their code review process. And yeah, they love it, I think. Still in production, yeah. It's just less general than DipED. So that one is done using dynamic analysis. So we listen when they run the build and kind of infer facts about the graph from that, which means that we only get one view of the conditions, right? Whatever the conditions were that were followed for that build, we infer the graph from that, and then we can tell you in the future, like, are you impacting the things from that build? The DipED approach statically analyzes the build file, so we get the full kind of complexity of all the conditions. Yeah, we don't have that yet, but that's really interesting. I'd love to chat more about how we can make that happen. Great. Thanks, everybody.